Uh, Today I'm meeting to speak on electrical essentials for HVAC engineers. Now, this first slide is showing you a typical air conditioning plant, right? Now, what area or what sphere on the electrical domain should an HVAC engineer require? At site, when construction is taking place, it's very important that an air conditioning engineer should be able to handle the electrical portion related to air conditioning. That saves the employer of employing another engineer, electrical engineer, for the purpose of the electrical part of the air conditioning. So what are those elements? Now, if you see this basic drawing, right? Now, what is all this? When you come across any tender document, if you look at the electrical section of the tender document, you'll find the tender document on the main section talking about the air conditioning equipment, and then you come electrical section is totally separate. You will come across these words 3C into 240 square mm XLP. Now, what is XLP? ACB, VCB, MCB, MCCB, TPN, VSS, VAF meter, CTPT. Now, so the electrical engineer should understand the tender documents, tender specifications, electrical drawings, right, to undertake the construction billing of the electrical section. We have now made a course. The name is Electrical Essential for HVAC Engineers. Now, electrical field by itself is a huge field. So we limit ourselves only to that portion, what you ought to know. First, part one, you ought to know the fundamentals. Second, measurements and testing. Why measurements and testing? You must be able to check the voltage. When the plant has started up, you must be able to check the current. What testing now? The most important thing is you must know about earthing in a central AC plant.
Sir, correct. As you said, uh, this is only we are limiting to HVAC engineers. This is very important point. HVAC engineer need not know how the whole distribution and the HT side of it and the bus bars. He needs to know the common which is required for his scope, HVAC scope to handle. Yeah, you're right.
So earthing is the most important. How earthing is made, how you test it, even after the plant has been put into operation, after a period of time, at regular intervals, let's say after every year, you must check the earthing of the earth pit. Because if it not properly watered, if it does not proper humidity in that area, then you're going to have earthing problems. Earthing problems, you'll get shocked like this that this kid is getting. Motors. Now, air conditioning is all about motors. There'll be motors. Must know what fundamentally a motor is. What is a motor? How it basically works? What's inside the motor? What's outside the motor? Basic things you ought to know. Then main LT panel. I've shown the main LT panel. What's inside? It's a box, it's a huge Elmira. What's inside this Elmira? You ought to know what's inside this Elmira. And the most important part is, in the construction area is single line diagram. You must understand the single line diagram according to which the project is being executed. You must
Exactly,
know
sir.
that.
Yeah. This is actually, sir, I came across this very common problem that reading a single line diagram is the biggest pain for HVAC engineer. Okay. They fail to understand which line is going where. So this is extremely important, which part works what and how it's getting connected to the and how the whole system works. Correct, sir. Please go ahead.
And believe me, it's not as difficult as it is made out to be. I'm a mechanical engineer, but I've mastered all this by virtue of doing it on your own. I've worked in industries. You see, if you're working in an air conditioning company, you're surrounded by like-minded engineers. So you get support from the support structure. But if you're working in an industry or in a factory, right, you have no support structure because the core activity of the factory is something else. I worked in Hindalco. The core activity is to manufacture aluminum. So in the air conditioning domain, I was the all in the end all. So you are without a support structure. And when you're without a support structure, you will very well get into the nitty-gritty of the thing and learn the subject. So I've learned the subject this way, and believe me, it's not so difficult. What appears to be lines and figures and symbols is absolutely very, very easy. The only problem is how to communicate, how the teacher or the trainer is going to communicate with his audience, with you people, with you engineers. So,
Sir, I have one question for all audience here before we straight to the next session, next slide. I wish all of you to answer in the type in the comment box if you know the answer of this simple question. What is the difference between cable and wire? It's a very common terminology, right? So please type the difference between cable and wire without any Google, please. And as an HVAC engineer, we must know what is the difference between cable and wire. Any answers?
there are 11 chats on it. You can go through this.
Cable is bunch of wires. Single wire and cable is a core. Yeah, this is very interesting answer from Rajendra Pindi. Sorry, I could Murugan. Yeah. Lot of answers. I'm looking for a specific answer. Wire is a single core. Yeah, that makes sense. Sir, would you please clarify them? Very interesting chat, sir.
Yes, yes, sir.
Well, very good answers, but I'll just, in simple language, I will tell you. Wire is of a single conductor, whereas cable is a group of conductors. Very simple answer. Sir, would you continue, please?
Yes. And then when you're coming across cables, just an extension to what Neeraj just said, you will come across armored cable and unarmored cable. What is this armor and unarmored, and where exactly it is installed? So in an installation, you must be very clear where the armor cable is being put and where the unarmored cable is put, because that involves a considerable price differential. Then little bit of controls. And lastly, but the most important, is understanding the electrical section of the tender document. Right, gentlemen? Now I go to the next slide. Now, what is voltage?
Yes, sir. This is also, even if the answers are available for this in Google, but still I have found many of people are getting confused with this terminology. So I think you can explain it better with animations.
You see, it is so simple. The fundamental thing is current is a flow of electrons, right? It's a flow of electrons. And how this electron is going to flow? Who's going to push it? Unless there's a driving force to push the electron, is not going to flow. That pressure is called voltage. Then the flow of the electrons. The electron can flow in a straight line, or they can flow in any direction, up or down. whatever. But if it flows in a specific direction as shown to you, right, it is called a sine wave. Then fund most elementary thing, this toy multimeter, clamp meter, every engineer should be knowing it. Every engineer should be knowing it. Be it mechanical, be it electrical, be it electronics, whatever. You must understand how this toy works. It's a very handy tool, without which you can do nothing.
Yes, sir. Can you please go back to the back slides, please?
Yes.
Yeah. This is the one which all HVAC engineers avoid, sir. The tool, this tool. They don't try to take this in hand because they don't understand what it is. But this diagram you have explained it very nicely. That
Okay.
what the function and all. Yeah.
Now I will now be a little bit more. Now, whatever you're seeing on the screen is handmade. No Google this thing. We only take help of Google if you have to show a picture. Only pictures are taken from Google, and that too also from company, what you call marketing sites. Suppose I have to show
So
a
this tool is as common. This particular climate is as common as for HVAC engineer. He has an anemometer. Without anemometer he cannot live. Okay. Same thing for electrical engineer. So this is very must.
you see, this is a jaw. This is a jaw. You put the wire through the jaw, and when current flows through a wire, it creates a magnetic field. That magnetic field goes into this jaw. This jaw is like a transformer. Laminated sheets are there. It's like a transformer. That magnetic field goes into this laminated jaw and is converted to current, where it is displayed out here on the display panel. You can
This,
check current.
current sensing jaw. What is the material inside the current sensing jaw normally it has to sense all this?
There's a transformer meter. It is laminated sheets. There's special material sheets, and they're called stampings. They're called transformer stampings.
Okay.
When it's surrounded by a magnetic field, it produces current, and that current goes there to be sensed by this electronic circuitry inside this, and the display comes here. They are basically called transformer stampings. Right, sir?
Yeah. Please go ahead, sir. Can go to next slide also. Well,
Yes. Yes. No, this is a motor. You people may basically come across squirrel cage induction motors, compressors and AHUs and pumps are all basically three-phase 415 volt squirrel cage induction motors. Now, the very latest is that in the AHU, the squirrel cage induction motor is now replaced by EC motors. EC motors mean electronically communicated. That is a BLDC motor, brushless DC motors. The advantage of this motor is it can be directly controlled electronically. This motor, what you're seeing on the slide, cannot be controlled electronically. If I have to vary the speed of this motor, I have to use a VFD, variable frequency drive, to control the speed of this motor. Whereas in BLDC, we don't need that. That is controlled electronically. So these new things are coming into the field. You ought to know what is it, right? And these colored rings in dotted shape shows you the magnetic field. Okay. The magnetic field induces another magnetic field in the rotor. There's a rotor inside this. Yeah, I think the next slide. Yes. Now this magnetic field rotates, and there's a rotor inside which drives the compressor or pump. Inside this black hole, there'll be a rotor. This magnetic field creates an induced magnetic field in the rotor. Now, when you have two magnetic fields, what's the magnet fields? Magnet. When you have two magnets, we know very well that if you have two magnets, they will either attract or repel. So the stator is rotating magnet and the rotor is also a rotating magnet. When two magnets come into position, it creates a motion. And that motion, we split the windings, right? Physically and electrically, and then that motion becomes rotary and the rotor starts rotating. As simple as that. Okay.
Sir, nowadays air conditioning, HVAC application and all, the commonest type of motor is preferred by squirrel cage induction motor or any other latest developments are there in the motors.
So this is what a motor looks like. Okay. Little bit you should know.
Okay.
Now we come to the most important thing. This electrical panel. It's a huge box. What does the box contain? So in our real contents, every element, this is outer enclosure, will come. The content is supported by voice. We'll speak like this. The drawing shows the general element of the following. One, outer enclosure. Then this gray color enclosure. Then it will say two, main bus bar. Then this main bus bar, red, yellow, blue, black will come on the screen, on the slide. Next, main power indicator and multifunction meters. Then these three lights will come and this is the multifunction meter. So our content is supported like a do-it-yourself module. Means you are being guided by voice. The voice says, first the text comes on the screen, then the voice speaks what the text is, and then it is followed up by whatever that element is will come on the screen. So it becomes very simple to understand this huge thing. Okay, and it's absolutely simple to understand how it is done. Then this is a single line diagram. We guide you how to understand a single line diagram step by step. Now, this being a very short half an hour session, so we've come to the main thing, how this comes here, how this is, what is this, what is VSS? VSS, remember one thing, that all symbols are directly related to the name. I can't put anything. I can't put KSP. No. V means voltage, S means selector, and S means switch. So VSS means voltage selector switch. It's so simple. What is AS? It is not AS. In Hindi called Gada. It's not Gada. It's ASS. A for ampere, S for selector, S for switch. It's as simple as that. V voltage, A ampere, F fuse. Notice what is MFM. M for multi, F for function, M for meter. Multi-function meter. It can read the energy, it can read the frequency, it can read various power factor, all those related things to electricals which you are not required to know. But you must know this is a MFM, the multi-function meter. Then we come to the main switch. 300A means 300 amperes can be carried by this switch. TPN, TPN, T triple, P pole, and neutral. Means there will be 3 conductors, right? And 1 neutral. So the total in this switch, there'll be 4 connections. 3 for conductors, red, yellow, blue. All these conductors are identified with the color, international color, red, blue, yellow. And N will be identified as black. So we'll have 4 connections in this switch. Then we come to MCCB. So what is MCCB? As I've mentioned, the first alphabet of the word gives the name to this switch or whatever device it is. M for is miniature. No, M is molded. C for case, C for circuit, B for breaker. But when you come to MCB, miniature circuit breakers. Then we have identified the cable. So when construction is taking place, you got a single line diagram, you have this is this. When you go to the site, you must see what that cable is. One cable, 3.5C means there will be 3.5. 3 will be full, suppose full square cable, let's say 240 square mm. 3 cores will be of 240 square mm and 1 core will be of 120 square mm, means 0.5. The 3 cores of 240 square mm will be R, Y, B, and 120 square mm, half core, will be in black PVC. So that is what you ought to see. Then you'll come across types of cables. XLPE, AL, AR cable. Now, this is the type of insulation, XLPE. Cross, X means not your English X. X means cross and not mathematically multiply sign, cross. L for linked, P for polyethylene, PE for polyethylene. AL means aluminum, AR means armored cable. So when you're building, you ought to make sure that this is an armored cable and this is not an unarmored cable. It invites a lot of financial differential. Then we come down here, cast resin CT 300/5A. Means, as I mentioned, that this conductor, when current flows in a conductor, it creates a magnetic field. So we have to capture that magnetic field. This is nothing but a transformer, as I mentioned in that multimeter, that clamp-on multimeter. This is a stampings transformer. When sort of a coil, when the magnetic field goes through this coil, it creates a current, and that current is measured here. So CT means current transformer, but it is not in the shape of a transformer, it is the shape of a coil. 300 means ratio. It must sense 300, and 5 is step down. That means this transformer will step down the current from 300 to 5 ampere, and that is the base level for measuring the instruments, right? So this ampere meter cannot be rated for 300 ampere. It will be a huge thing. So we bring it down to 5 ampere. So this transformer will create current of up to a maximum of 5 ampere, which can be sensed out here. Proportionately, this reading will deflect in the same proportional. Okay. Ampere will be reading from 0 to 400 amperes as a multifunction meter for all your basic functions. So once you understand this single line diagram, then you are a master. You can handle the electrical installation, because at the end of the day, it's all about money matters. You can't undertake the measurements, you can't certify bills, then you're unable to perform the work of an electrical engineer. Other things, of course, are very simple to understand. It's not a big deal. So we come to next slide. Here we tell you the basic symbols. And again, you will be guided. You will be guided. In any electrical drawing, you will find legend. This is not what I have fabricated. People may have different symbols. It can vary. Some people put in this way. Whatever it is, in one corner of the, I think if you've seen the drawing, at the right-hand corner is the name of the architect and the client and this and site location. And normally on the top side, on the right-hand side, we have the legend. What are the symbols mean for in that particular drawing? So you need not have to mug it up, or you not have to memorize it. It's there. The only thing you have to go there and understand, okay, this means this, and then you can relate to that symbol in the drawing. Then little bit of controls, how these things work. Now, if you see the color, the line is changing, the current is flowing, and all the contacts of all the controls are in series. Okay, they're in series with the no volt coil of the contactor. So if the current flows through all the contacts, then this no volt coil gets the supply. It creates a magnetic field and pulls the plunger, and all these contacts come into circuit. Now this current from this top point will go to this contact, to an overload relay, and then go to the compressor motor. I hope I am clear. These are very basic fundamentals. Giving information, it has two elements, means how it can be simplified. We specialize in simplifying engineering. Engineering is difficult, it's complicated, but our objective is to just simplify that for any layman to understand. With that, supported by self-created drawings, self-created animations, and I think this speaks for itself. If we provide it with voiceover and with in a multimedia mode, so video mode. So when you read, listen to it, and you see the things happening, it's well understood. Now we go to next slide. Thermostat. How it works. You can see how the contacts are moving and closing. We explain it out there. When the slide speaks for itself, when it speaks these words, and you see this motion, it's simple to understand. Now that was mechanical on-off. Now there is no mechanical switch. It's very simple. Now, the transistor is a switch. How many types of switches are? One, we have a switch where you have to switch, both physically switch on and switch off. The second switch is the current operates a contactor that switches on and switches off. Means first is 100% mechanical, that you physically have to walk up to the switch and turn it on. That is 100% mechanical. Then semi-mechanical, where you operate contactor where you operate a contactor, then the contactor does the rest. The third is electronically, right? Where a transistor, IC, you must have heard about IC. IC is a component comprising of hundreds of transistors. Now this is earlier we never had ICs. We had the transistor and this transistor conductor. We'll wire it up like this. But when an IC, they're all wired up in a particular configuration, right? Number of transistors to create a specific operation. So when the transistor conducts, the positive goes up to here, the circuit is completed from this to the transistor, and it operates the relay. Ultimately, it's all about energizing a contactor, energizing a relay. Once you energize a relay or a contactor, right, you can operate anything. Here I'm operating a fan, right?
Yes, this animation is very powerful. It's explained in very simple animation. This difficult concept of NTC sensor controller very easily. Thanks.
Now we are also making a complete MEP course. So sometimes you might come, once today you're doing mechanical, tomorrow you'll do electrical. Then sometimes you might say how you do the plumbing, how you take the measurement of plumbing. and things like that. And so we are compiling a complete MEP course. Now, that will have, for example, this NTC. Now, what is this NTC? Now, this transistor will conduct, but when will it conduct? Will I go there and switch it on? Why should I go there? I don't want to go there. I want to sit where I am and it should work by itself. NTC is a semiconductor. Negative temperature coefficient is got a name. Means this semiconductor, the resistance of the semiconductor will change according to the environment temperature. What is that change in the environment temperature? NTC means when the environment temperature increases, its resistance decreases. Fine. So I put the resistance out here in front of this base. The current has to flow to the base to make it to conduct. Now, this resistance will change accordingly. So I designed the circuit in such a way, for example, at 24 degrees centigrade, the resistance is, let us say, 10 ohm. And I designed the circuit in such a way that this transistor starts conducting. It starts conducting. And in the case of fan, we have a compressor, it starts running. Fine. So at 24 degrees centigrade, the resistance is 10 ohm of this end of the NTC, and my fan is on. Now, when the resistance becomes, let us say, when the ambient becomes, let us say, 23, okay, then the resistance of the NTC will also change, will also reduce. When the resistance reduces below 10 ohm, let's say becomes 9.5 ohm, then the current cannot flow because of the higher resistance. The moment the resistance increases, right, the current will cease to flow. That means when the resistance changes from 10 to 10.5 ohm, then the current will no longer flow and the transistor will no longer run. That means I have the thing is totally automatic. I'm sitting relaxed. I need not go to the machine. I need not get up. I have set the system in such a way, right, that whenever it is 24 degrees centigrade, my AC is running, giving me cool air. But the moment the temperature goes below 24, let's say 23.5, then it stops. This half degree, what I'm saying, is only available with inverter compressors, where the speed can be varied from 10% to 100%. But in the normal fixed speed compressor, this is plus minus 2. That means 24 and the next point is 22. So when the temperature becomes 22, the machine stops. When the temperature becomes 24, the machine starts. This 2-degree gap is not very comfortable. So technology is developing day by day. Half degree does the job. Refrigerants are changing day by day. Global warming is increasing day by day. This is resulting in an exponential growth in the air conditioning sphere. So air conditioning is resulting, going to is very promising for future engineers. Then you come to the tender document. Now look at the tender document. AC chiller, IP rating.
Stop you here for a moment.
Yes, sir.
All those who have attended this session are going to attend. All the participants who will be staying till the end of the session and asking active participation with the help of questions, we are announcing a free trial of 7 days for best unitary practices in air conditioning systems, how the gas charging is done, how the evacuation is done, which many HVAC engineers don't know. So we are giving that free trial of that particular course for 7 days to all people who will be staying till the end. and asking and interactively participating in the section and clearing their doubts. So those who are, we encourage all of you to ask questions till when the session ends. So we will appreciate that. So our mission to upskill the HVAC engineers, we feel that it would be successful to a certain extent. So please stay till end and enjoy this session full of animations what Mr. Dhawan sir is giving. So we can send you across the code once the webinar is over. So you can access that particular course for 7 weeks. Sir, please
Thank
go ahead.
you. Thank you, Neeraj. Now, if you see carefully, we make our own animations. That means what is in my mind, I put it in the form of text. And then I convert that text into a motion which I want to express. So what I'm expressing, what's in my mind, you can see exactly what's in my mind. This animation is made accordingly. This text and the animation is correlated to what I have in my mind to explain what is going inside the machine. So this animation is our creation. It is not available anywhere from Dr. Google or Dr. Facebook. This is to the extent what you need to know. What you need not to know, we will not deal with it. What you exactly need to know, because the moment we go to what more and more things that only confuse the issue, you have to be empowered to handle your limited specific area, a master of air conditioning in all aspects. So we have a complete program, how to design ducting, how to fabricate ducting, how to install ducting, everything is there. That will be very helpful, complete. You can say it's going to be an encyclopedia of the very, of its own kind. It's an encyclopedia full of animation, and if you notice, the English is very simple. We've tried to make it as simple as possible so that there's no English issues, there is no understanding issues, and everything is in a step-by-step module. Okay, gentlemen? So if you see this fan running, you will not get it anywhere in the world. It's only with us.